Here is a blockchain or chain of blocks. We have our first block here, block number 1, and it has this value as a nonce. There's a data rectangle, but the new aspect of the blockchain is right here, previous, right above the hash value. I'll explain what this is shortly. So we can take a look and we see that there are other blocks as well. Block 2, block 3, and block 4 are here for the example. If you notice something, you see that all blocks have different hash values as well as different previous values. And if we take a closer look, we see that the value for the previous label is the same hash value that the previous block has. So for block number 4, if we ignore the 4 zeros, we see that the previous hash value is listed as EAC36. The previous block has a hash of EAC36. We can look at the previous value for this block as 9382. The previous block has a hash 9382, and so on and so forth until we reach block number 1. And if you see, this is actually how they are chained together, and it's how the term blockchain came into play. The first block actually has no previous block, so the value for previous is actually all zeros. Notice how the first 3 blocks are mined due to the 4 leading zeros in their hashes? In this demo, we showed a mined block with a green background. However, the last block is not mined, which means it is still accepting new transactions. We are showing unmined blocks with a red background. So let's add a new transaction. So I'll go in here and I'll add transaction 3. One of the most, and now I'll actually mine it. So I'll mine it. One of the most powerful aspects of blockchain technology is the chain of blocks is immutable or temper-free. Let's try something. Let's try to change the data for block 2. So I'll go in and I'll remove transaction 2. And notice how this block and the subsequent blocks are in invalid states or are considered broken, as seen by the red color. No problem, I can remine all of the broken blocks again. It'll take some time, but so what? So now I'm remining those blocks. So now they're all in a valid state. Does that mean that anyone can change the transactions in a blockchain, mine them again, and remain unnoticed? The answer is no. Why is that? Because in a real blockchain system, there are thousands of copies of each chain distributed all over. All copies are identical at all times. This is something called distributed blockchains.